All right, these are level 4 equations. So in level 4, you have to could do some combining of like terms in some kind of way before you solve the problem. At least that's recommended. So for example, here is my equal sign, and I have two variable terms on the right side that can be combined together. I have positive 3n, positive 8n, so altogether I have positive 11n. And then I still have a negative 4 or a subtracting of 4 over there that I need to take care of, and 12 on this side. Now that I have a regular two-step equation, just add 4 to both sides using the addition property of equality, and we'll have 16 equals 11n. Ugly problem, just divide both sides by 11, totally fine to get 16 elevenths equals n. 16 elevenths is not easy to write as a decimal, so you might as well leave it as a fraction. You can leave it this way if you want as an improper fraction, or you could make it 1 and 5 elevenths equals n. Here's a different problem. In this case, notice that the equal sign is over to the right, and our like terms here, we have negative 5p and positive p. So altogether we have negative 4p. And 3 is our constant. We just bring that down. 3 minus 4p equals 8 is a regular two-step equation. 3 is positive, so we're going to subtract 3 in order to move the constant term to the other side. And we're left with negative 4p equals 5. Now when we divide both sides by negative 4 to isolate our variable p, we get negative 5/4, which is the same as p equals negative 1 1/4. Because the original problem doesn't have a decimal or a fraction, you could write this answer as p equals negative 1.25, and that would also be acceptable. When the problem has decimals up here, you want to make sure your answer is in decimal form if it's not a whole number, and if there are fractions up here, you want to make sure your answer is in fraction form if the answer is not a whole number. Last question I'll go over in this type of problem, because it's not that much new stuff, is we have here 2q, combining that with a negative 8q. Well, we have 2 minus 8 gives us 6q's, but they are negative because the 8 is negative. And we have positive 5 as our constant here. And bring down our 14. Now subtract 5 from both sides. 14 minus 5 gives us 9. 9 equals negative 6q. We want to get rid of the coefficient, negative 6, so divide both sides by negative 6. And we get negative 3 halves equals q. Negative 3 halves can also be written in this case as negative 1.5 equals q, or as negative 1.5 equals q, because again, there's no predetermined format since the original problem was with whole numbers or integers. I hope that information is helpful.